All right, look up here. Formation of ions. This will look exactly like your chart in a second. So basically, I'm showing you how to do your paper. We're not really learning anything new necessarily. We're just kind of putting the two things we learned yesterday together, trying to kind of review. Now, the octet rule. Remember yesterday, all my noble gases have 8 valence electrons. Octet means 8. So 8 is a full outer shell. That's why it's called the octet rule. It says 8 is full. 8 is happy. 8 is stable. If they have 8 in their outermost energy level, they don't bond. They're happy that way. So atoms react by changing the number of electrons so as to acquire a stable electron structure. The goal is to have an S2P6, which has 8 electrons in it. The only one that's different is helium only has 2 and hydrogen. Hydrogen and helium only need 2 to be happy, but everything else needs 8. Just hydrogen and helium are really tiny atoms, and they happen to be full and stable at 2. All right, now I'm doing this, the atoms form ions. We learned that word yesterday. All an ion is an atom with a charge. That's it. If it has a charge, it's an ion. All right, now I've been looking at this example up here. This is sodium. Remember, sodium is Na on the periodic table. This is its electron configuration we did in our last unit. Its outermost energy level is a 3. These would be underneath it, so like literally under the shell of electrons. The 3's on the outside. There's only 1 electron in it. So it only has 1 valence electron. Now, yesterday, we learned that it's going to become a positive by 1, is how we label the periodic table, and it loses 1 electron and becomes an ion. But why does it do that? So kind of today we're going to put that together as to why. When you think about sodium having this 1 on the outside, to be happy it wants 8 on the outside. Now it has 2 choices to get to 8. It can either bond with something and steal 7, and steal 7 electrons to have a full octet, or it can lose 1. Both take the same amount of energy to either gain 1 electron or lose 1 electron. So what would be easier? To gaining 7 or losing 1? What's a lower number? 1. Whatever is the lower number is the one it's going to do. So instead of gaining 7, it's going to lose 1. That's why it loses 1. When you lose 1 negative thing, you become positive. So that's why it makes a positive ion, because it's easier to lose 1 than it would be to gain 7. All right. Now, last thing for fluorine, when it loses that 1, this literally goes away. It loses it. So now its outer shell is this, 2s2, 2p6. How many electrons are in that? 2s2, 2p6. 2s2, 2p6. What's 6 plus 2?
8.
8. Has 8 now. Okay, it's 8 and a half. All right, fluorine. We're going to do fluorine next. Fluorine is 1s2, 2s2, 2p, within 2p? Yes, 2p5. That's fluorine. 1s2, 2s2, 2p5. So when I'm looking at fluorine's electron configuration, its outermost shell is a level 2. That's the farthest it goes. It only has a level 2. In its level 2, it has 2 plus 5 electrons. So it has 7 valence electrons. Would it be easier for it to steal 1 or have to give away all 7? Yes, because it only had 1 to lose. It has 7 to lose now and only 1 to gain. You're trying to get to 8. Losing 7 is harder than gaining 1. It's going to gain 1. Now, if it gains 1 electron, it's gaining a negative thing. So that means that fluorine's ion charge is -1. It gained 1 negative thing. When I write its name, you don't actually want to know this, but we'll go ahead and write it. Anytime something is negative, it is no longer having its original name. They change it from fluorine to fluoride. Just anything that has a negative charge, they change their names to I. We'll talk about that more in our next unit, but for now, you know it. So notice how when something is positive, I left its name the same, it's still sodium. When something was negative, it was fluorine, now it's fluoride. So when things are negative, they change their name. It's just a naming rule. All right, we're gonna scroll down and do this chart. This chart is just like your assignment. I've written. Got to scroll down. Okay.
Yeah.
All right. You haven't got your periodic tables out. Get them out so you can do this with me.
We've been,
Yeah.
Find barium. Barium is Ba. Find it. Okay. Are y'all looking at barium? Just got your periodic table out. I've said now 5 times. Find barium. Okay. Where is it? Point to it. All right. It says up here, number of valence electrons. We underlined that yesterday. Whatever number column it's in, that's how many valence electrons it has. So barium has this many. 2. That's how you know how many valence electrons it has. It's just the column it's in. It's in the second column, so it's 2. The Lewis dot structure is the last thing we did yesterday. You put the symbol Ba, and then you put the dots around it for how many dots it has. Only has 2. Remember, it was that weird format. We did an example again. 1, 2, 3, 4, 5, 6, 7, 8. So if it only has 2, and it's like that. Number of electrons lost or gained. So again, this is, you gotta think about it here. It has 2 on the outside. It wants 8. It's sure it's plus 6, but it would be easier to lose 2. Then it just have full undershell. So it's always, would it be easier to lose 2 or gain the whole 6? Always the lowest number. So it's easier to lose 2. If I lose 2 electrons, I'm losing 2 negative things. So it's becoming positive by how many? 2. How to write the symbol is you just put Ba and plus 2 at the top. Always goes at the top. It's not off to the side, it's at the top. All right, nitrogen. Nitrogen, find it. It's an N.
-3.
No, not the charge.
Oh.
I want to know the number of valence electrons it has.
Nitrogen.
-3. It'd be 5.
That's what it says at the top.
I know, but y'all were supposed to label 2 things yesterday, and apparently only labeled 1. I didn't say the charge, I said the number. You were supposed to underline the 5 and the 15, or underline the 5 and 5A. You highlighted it, it's 5.
I say 5. Okay. Yeah, I looked at it.
So when I'm making its dot structure, so it's 1, 2, 3, 4, and 5. I literally wrote it up there.
It's on the other side.
That too, but I did put it right there.
Yep.
Now, it has 5. So your choices are always lose all 5, so lose how many it has, or gain as many as it needs to get to 8, which is 3.
Gain.
Which one is a smaller number?
It'd be gain. 3.
Gaining 3, that is a smaller number. Gaining 3 electrons. Now if I gain 3 negative things, then I have a -3 charge.
Crazy.
When you write its symbol, it's just its symbol with the charge at the top. There you go. What?
Wouldn't it be easier just to drop 3?
It has 5. It has 5. You either lose 5 or gain 3. So that's 8. 3 is a smaller number.
There's something going
All right, scroll down. For carbon, find me carbon. How many valence electrons does it have? It does, it has 4. Okay, so carbon has 4 valence electrons. So when I draw its symbol, it's gonna be 1, 2, 3, 4. Now this is a weird one. Number of electrons lost or gained. Now, what I've been asking you, is it easier to lose or gain what has 4? So you can either lose 4 or gain 4. That's the same.
on.
They're the same. So this is why we wrote on the periodic table both. Because it is just as easy for it to gain 4. Oh, let's see, gain 4. It is just as easy to gain 4 as it would be to lose 4. They're the same number. So which one it will do depends on what element it meets. It will do whatever. Basically, it's just a very free-flowing element. It makes tons of bonds because it's totally fine with whichever case. Now, if it gains 4, that'd be negative 4 charge. If it lost 4, it'd be positive 4 charge. So it will do both. It doesn't care which one.
Anything that has a 4 in the.
Anything that has 4 in that column could be positive and it could be negative. Either or. So when I write its symbol up here, you have to write both. Either one of those is correct. You can do either one. All right, for neon.
Whoa, what happened?
Find me neon. How many does it have?
Hold on, wait.
It has 8.
Like 8 slides.
8 is our happy number. So when I put in neon symbol, 1, 2, 3, 4, 5, 6, 7, 8, it's full. 2 on each side is full. 8 is our happy stable number. So when it says, is it going to lose or gain? No, it doesn't want to lose. It doesn't want to gain. It already has what it wants. It has 8. So no, it's not going to lose or gain electrons. It doesn't want to. 8's then a magic number. So what charge is it going to make? It's not going to make a charge. It doesn't want a charge. It's already happy. It's already stable. It has 8. So then when I write its ion symbol, it doesn't have an ion symbol because it doesn't make ion. Because there's only one row of them on the whole periodic table. Now the next one is an exception to the rule. Why I'm showing it to you, hydrogen and helium are like this. Helium only has 2. Now why I say that? What row? Helium's in the 8th column, right? So you think it has 8.
No.
But it doesn't, because how many electrons does it have total? What's helium's atomic number?
2.
It only has 2. So it can't have 8, and it can't have 8 outside electrons if it only has 2 electrons total. So helium is our special one that we actually write it like this. I know normally we do 1, 2 on opposite sides, but helium is full. Remember, hydrogen and helium can be full with 2. They're small and they're exceptions to the rule. So we draw in a different way, just saying like it's done. That's actually all helium can hold. So will it lose or gain? No, because helium is actually full with 2. Helium is a noble gas.
Oh my God, you forgetting.
So it won't make a charge and it won't make an ion. So that's why I'm showing you helium. It's the only one that doesn't have to have 8. It's special.
On the periodic table.
Yes, just helium and hydrogen. They are happy with 2.
Is that what makes it worse?
All right, so that's the end of notes. That's literally your worksheet on the back. So there you go, start doing it.
Oh, wait.
You can stop recording.
Oh.